All right, so picking up where we left off, just breaking this up into two videos. So this is all the examples where there are 4 sites, but just to remember what we've done, all right, when you count up, all of these add up to 4 sites. This is counting attached atoms and unshared pairs. 4 sites, the clouds, the pencils, if you will, go to the corners of a regular tetrahedron, so the clouds will be tetrahedral. All I'm going to ask you is this column, but this is how you get there. If all of the clouds are attached atoms, the shape is tetrahedral. If you pull one of them off, take one of the pencils off, right, then you have a trigonal pyramid. If you take 2 pencils off, it's bent. This is 2 unshared pairs. If you take 3 of them off, it's going to be linear, right? All right, so let's go. We're going to finish this up. So this is formaldehyde. Now, the Lewis structure would have unshared pairs here, but we're going to look at the carbon, not the oxygen. That's why I didn't do it. So let's look at the carbon. Okay, how many atoms are attached to that carbon? Ready? There are 1, 2, 3. So remember, it's attached atoms, it's not bonds. If we count bonds, it's always going to be 4. A double bond is 1 attached atom. A triple bond would be 1 attached atom. So it's important that you count attached atoms, not bonds. How many unshared pairs are on the carbon? There are 0. No unshared pairs on the carbon. That means this only has 3 sites. So this is where you can take your pencils, take 3 pencils, and try to get them all as far apart as possible. Just hold them in your hand. And when you do that, you're going to find that the clouds, the pencils, are going to be trigonal planar. Okay, so this is like triangular. Now there's trigonal pyramidal, but this is trigonal planar. Planar means flat. So basically it's going to go to the corners of an equilateral triangle. That would be your ball and stick. Right, and the bond angle, this bond angle here is 120. Again, you do not need to memorize the numbers. It's going to go a little faster now because it's all examples. There's a space fill. And there's the summary sheet with this. Okay. All right, we're going to do another example now. So we're going to look at the sulfur in sulfur dioxide, just the sulfur. We're not going to talk about the shapes around the oxygen here. We're going to just do the sulfur. All right, so the sulfur has, we could do these later, but the sulfur has 1, 2 attached atoms. The sulfur also has 1 unshared pair. That means you have a total of 3 sites. So if you're going to try this, you would hold 3 pencils in your hand, 1, 2, 3. And then remember, think of the unshared pair as an invisible cloud, so get them all arranged, and then just take that one away, but don't move these 2, and that'll be the shape of the molecule. The clouds, though, before you take that pencil away, will be trigonal planar. If there are 3 sites, the clouds are trigonal planar. All right, there's the ball and stick. Software just wouldn't let me do it that way. All right, now you take one away, it's bent. It's not bent the same as water, though. If you remember, water had the bond angle of 105. This has a bond angle of about 117, actually. We'll talk about why it's not bent as much as water. Maybe you can figure it out on your own, but I'll let you think about it for a moment as I go through these slides. All right, so again, there's no wedges and dashes here. There's your space fill. It looks kind of like water, but it's a little bit more open. Now, why is this more like 117, whoops, where this is 105? And there's a couple of answers to that. One, if you look at water, water has 4 sites. Sulfur dioxide only has 3. 4 things are going to have to be closer together than 3 things. Within the same space, it's going to be more crowded, so they're going to be closer together. That's one reason. Another reason is water has 2 unshared pairs pushing the bonds closer together. This only has 1. But the bottom line, they're both called bent. They're just, the water's more bent. I only have a couple more examples. Okay, here we're going to look at this oxygen. Okay, just look at it. And I would be specific if I asked you what atom, but usually I'm just if I don't say anything, I'm asking for the central atom. All right, so if we look at this oxygen, how many atoms are attached to this oxygen? Just 1. How many unshared pairs? See how important these unshared pairs are? And we're not counting all the unshared pairs in the molecule, just on this atom. This atom has 2. Remember, we counted this one when we did the sulfur. We're going to count these 2 because we're talking about this oxygen. So it's 2 unshared pairs. That means there's still a total of 3 sites. So there's your triangle. 1, 2, 3 through your 3 pencils. Right? So the clouds are going to be trigonal planar. Now you remove two of the pencils, but keep the shape the same, and it's going to be linear. Right? Take two away, it's going to be linear. There's side by side, okay, and then here's the summary sheet. All right, I'll go through the whole summary sheet. The last slide will be the whole summary sheet. All right, let's look at carbon dioxide now. We're going to look at just the carbon. So how many atoms are attached to the carbon? That's right, just two attached atoms. So now take two pencils, try to hold them in your hand and try to get the tips of the pencils as far apart as possible. And what you're going to find, there's no unshared pairs, you're going to find the two sites, I'm getting ahead of myself a little bit here, that the clouds are going to be linear. There's pretty much nowhere to go from linear. All right, there's your ball and stick. Bond angle is 180. Okay. There's the space fill. That looks like a colorful hamburger. All right, so that's two sites. Okay, one more example, and then we'll summarize this and be done with it. Okay, we'll look at nitrogen. Both of these are the same, so we'll just pick this one, this nitrogen, but this is the nitrogen molecule. Nitrogen is a very, we'll talk about nitrogen actually quite soon. Nitrogen is a very, very stable, very unreactive gas. To make it react, you have to break 3 bonds. All right, so we look at, just pick one of the nitrogens. They would both be the same. There's only one attached atom, right? How many unshared pairs on the nitrogen? Just one. That means there's a total of 2 sites. We just said 2 sites, the clouds will be linear. So you have your 2 pencils in a straight line, then take one of them away for the unshared pair. Okay, and it's going to be linear. Side by side, there's your space fill, and this is the last slide. So let me summarize this, and again, I can't show you, I could do a separate video, but I don't want to make you watch too much more. But imagine once you determine the number of sites, so you count the you draw the Lewis dot structure, you count the attached atoms and the unshared pairs, you add them up, that's the number of sites. That's when you put some pencils in your hand and hold 4 pencils, hold them all, try to get the tips as far apart as possible, but keeping all 4 in the same, attached to the same center, and you're going to find that the clouds, the pencils will go to the corners of a regular tetrahedron. If they're all attached atoms, the molecule's a tetrahedron. If you have one of them, pull one of them off, that's a trigonal pyramid. That's one unshared pair. So the unshared pairs, just pull a pencil away. 2 unshared pairs, bent. 3 unshared pairs, linear. If you wanted, instead of using pencils, if you want to blow up some balloons, that's an even better example. Right? So for this one now, the CH2O, you can review the slides if you want. You have the slides in the Canvas shell. Right? There are 3 attached atoms, no unshared pairs. So now every time you have 3 sites, take 3 pencils, try to get them as far apart as possible, but keeping them held together. You're going to be trigonoplanar. Right? By the way, there's trigonopyramidal and trigonoplanar, so you can't just say trigonal. You have to specify. Right? So it would be trigonoplanar. And again, if the clouds are all attached atoms, the shape of the clouds in the molecule will be the same. If you take one of them away, it's bent. If you take 2 away, it's linear. Then once you get down to 2 sites, everything's going to be linear. Right, it's a little tricky to visualize this stuff, but I think you guys can do it. And that's it for these slides. And this should get you through a good chunk of homework and I'll tell you, you'll see when it's due. Right? But this is stuff that you want to spend some time with shape. Some people are really good at visualizing this stuff. Some people aren't so good at it. It's just how you're wired. Me personally, I had a lot of trouble seeing this. That's when I came up with holding 4 pencils in my hand to help visualize. And in the old days when I was doing it, we didn't have computer visualization like we do now. All right, so that's it for this set of slides. Have yourself a good one.